Hi, and welcome to this Reniway Edge tutorial. Today, we'll demonstrate how Reniway Edge can connect any machine, regardless of its type. Machines often vary greatly. They use proprietary data interfaces, different communication protocols, unique data types, and different tag definitions. In this example, we'll be working with 3 machines, each with its own way of indicating productivity status and using different units of measurement. These variations make it difficult to build data-driven applications for calculating key performance indicators like OEE or comparing data between machines. The goal of today's demo is to use Reniway Edge to create a unified dataset, making it easy to integrate the machine and draw meaningful data correlations. For today's demo, we'll be using this live setup using a backup PLC which implements a simulated machine. We'll be connecting the PLC to the Reniway Edge platform using field connectors. A field connector is a software block implementing an industrial protocol. In this case, we'll be using OPC Unified Architecture. To show the flexibility of the Reniway platform, we'll also be adding a sensor. This is an energy measurement device which uses Modbus TCP. Once connected, we can read out different tags like machine state, air pressure, motor temperature, and energy data. As a next step, we will transform the data to a unified data model. We can also add annotations with labels. Finally, we'll be using enterprise connectors to integrate the data into different data platforms. This can be the cloud, like Azure or Amazon, a manufacturing execution system, your own data platform, or a dashboarding tool like Grafana. All right, let's go ahead and open our Reniway Edge software. So now that we have switched to the Reniway configuration web application, we can start adding field connectors to the flow page. We will start with connecting the backup PLC using an OPC Wave field connector. Let's enter the correct endpoint URL of the backup PLC. And once the icon becomes green, we are connected. So then we can start adding data points. The view that you see here is a live browsing view of the address space of the OPC Wave server of the backup PLC. So then we can start browsing the address space and find the data points that we're interested in. In this case, it's the air pressure, the machine state, and the motor temperature. Once we select the nodes, the live values are immediately available in our field connector block. So next up is the energy measure device. We'll add a new field connector. In this case, it's a Modbus TCP device. We'll enter the IP address and add it. Modbus TCP is a register-based protocol, so it does not support live browsing. For adding Modbus data points, we have built a CSV import-export, so you can easily manage your data points in tools like Excel. So let me show you an example. So here, each row represents a data point, which has a name, an address, and a type, and some other properties. So once we upload this CSV file, the data points will become available. There we go. So now we have connected the field devices and we can go to the next step. So we will bring our field connector data together in a data mapper object. This object represents the real machine and allows data to be transformed into a unified data format. So let's add the data mapper object. Let's call it the metal forming stamping machine. There we go. And next we want to connect some field properties to this data mapper object. So we've created a convenient auto mapper feature. So if you link them together, you can select the properties you want to map. Next, we will do the energy measure device. And in this case, we're not interested in the MAC address and the model. There we go. So all the data we need for the metal forming stamping machine is available in the data mapper object. So next up, we will add some transformations. The first transformation is to calculate the total power. The energy measure device only shows us the individual phase powers, so we want to add them all together into one total power figure. So to do that, we will add a transformation. Let's call it total power. We can then select the input properties. So phase A, phase B, phase C. And we can select an output type. Let's do a double. And now you can see the transformation view. This is a simple JavaScript editor where you can transform, calculate, do all kinds of operations to the incoming data. This function is called each time one of the input properties changes. So in this case, we want to make a sum of the phase A, phase B, phase C, giving the total power. And we also want to make sure that there's only two figures after the comma. So there we go. We save it. And immediately you see when one of the properties changes of the phases, the total power is calculated. So one transformation I want to show you is about the machine state. So the back-of PLC is programmed using the PACML standard. This standard defines a state machine to represent what the machine is doing. It is a quite extensive state machine with, I think, 14 different states, which is a bit overkill for what we want to achieve. And that's why we want to map it to the OPCOA for machinery state machine, which only has 4 states: executing, not executing, out of service, not available. This is often used to calculate things like the availability component of OEE. All right, so let's create the transformation. So we'll add a new transformation. So PACML to machinery. And the input is the machine state coming from the back of PLC. We'll make it into a string. And let me copy paste the function which I've prepared. So the state coming from the back of the PACML state is provided as a number. So in this switch case function, we will transform that number into a string. So there are 40 states which will be mapped to 4 strings. So let me test it out. And then if I change the state, you will see it actually in action. So not executing, and if it turns green, it will be executing again. Yep, there we go. So this is the part about the data mapper. So to reiterate, we have created some field connectors, added properties, data points to it. So we're reading out live data from 2 different devices. We've created a data mapper object, which represents the machine, which collects then all the data from the different field devices. And we have created 2 transformations, one calculating the total power and one that maps the state machine of the back of PLC to the machinery state machine, which we like.